Welcome to Technological Change here in Input-Output Analysis, Module 4. I also give you here a brief overview what technological change is and how you can incorporate that into your input-output models. So I pointed that out several times already that the static model and input-output tabling can't incorporate really technological change. Because technological change comes with different production functions and different goods and services and therefore demand. So the whole economy changes through technological change. Think of all the things that developed out of the fact that we can suddenly have a phone in our own pocket. 40, 50 years ago, many of the industries that are depending on mobile phones didn't even exist. So this technological change has far-reaching impacts on the economy and therefore must be incorporated into input-output models as well, especially if you look into the future. So we differ different kinds of technological change. We have neutral technological change, which is a uniform productivity improvement across all inputs. So this is the case where everyone gets better to the same amount. We have also biased technological change in the economy. Here, change is favoring specific inputs, and only a few inputs or industry get better or get even worse through technological change, so you have an unequal development throughout the economy. Disruptive technologies are a little bit messy. Disruptive technologies are large-scale shifts that completely alter and change the structure of input-output tables. Consider here, for example, the new technology of cold fusion. It would completely revolve any kind of energy production as we are familiar with today. This is a shock to the economy, a technological shock, which we don't know when and if it will happen, but it's something we might want to incorporate into our models or allow at least the possibility of such a shock to it. And as I mentioned, technological change quite often comes with different production functions. And if you recall the excursion we had earlier on different production functions, where I talked to you about the linear production function, Cobb-Douglas production function, Leontief production function, or active analysis production function, that's here the point where I show you a little bit how they can be incorporated. Because these alternative production functions moving beyond the Leontief production function, they allow explicitly for substitution and production flexibility. So therefore, they can incorporate technological change. And what it requires quite often, especially with the Cobb-Douglas function, is that you have elasticity parameters or productivity parameters for the economy, which then can be incorporated into the output. I give you a brief glimpse into how this can look. In the case of the Cobb-Douglas function, for example, you've replaced the fixed coefficients of your technical coefficient matrix with proportional relationships based on the Cobb-Douglas structure. So we suddenly have those substitution effects incorporated into an equilibrium model. And from there on, it's quite straightforward to do the math if you know how to do it. And because it would take a lot of time to show you here, I just tell you this, it's a lot of work, it's a lot of fun work if you want to do that, but also you wouldn't be the first one to do that, so there's a bunch of literature that tells you how this can be done. I hope this helps you a little bit to see how you can incorporate technological change into input-output tables by changing the production function that you assume.